What's going on, everybody? Welcome to CS540 Week 10 First Order Logic. If you're new here, welcome. Be sure to check nearlyblog.com and click this image and you are able to view this page. So this week we talk about the first order logic. So I would like to talk some basic concepts about FOL and some sentence translation, which is really important. And also the equivalence of formulas. So let's just jump into our tutorial. The reason why we need to use the first order logic is, so last tutorial we introduced the propositional logic. So for propositional logic, with those logic signs, we can just like assign one condition at one time. However, when we are especially for artificial intelligence, we have to include a lot of scenarios in one case, or you could say in one formula. So we have to use first order logic in order to include a lot of scenarios in our case. So first of all, I like to talk some basic concepts. Hello. First is constant. So as we know, in mathematics, constants can be any numerical values. Here, yes, those numerical values are constants, but we can also have some specific names. For example, my name is Nian, or CS540. Those are also constants. The second thing is variable. So in contrast to constant, variable is something that is not determined. So for example, x, y, z are very common variables that we used in first order logic. The third thing is function. So I believe in the last tutorial we actually introduced what is the functions. So functions can just be something like square root and some values inside. You can either put x or not, but here probably I just put 4. So here the term is just a function, and of course can have multiple inputs. Here I just put 4 since it's just a square root function here. The fourth concept is a ground term. So the ground term is actually a term that has no variables. So for example, the square root 4 here is actually a term, is a ground term, or Nian is also a ground term here, since they don't have any variables. The fifth thing is item. So this is somehow important now. So item is the smallest true or false expression. So what does this mean? So as you can see, we can have two different things. One is we can have a function in it, or you could say that is the predict. So you could say like love. So I just love girls. So I can put the first variable as Nian, that is me, and I love girls. And whether this is true or not. And of course, the answer is absolutely true. I love girls. The second thing is you can use the equation equal sign. So you may, like, for example, the function is population. So I'm asking the population of China right now is around 1.4 billion. So as you can see, actually the things here, these two functions, actually, so I just put a comma here. So these functions are just in the shortest term that they can be in order to present either a true or false statement. And of course, we can add more and more stuff, like we can have an and, or something, all kind of thing. But they're not atom anymore. So just remember, atom is the smallest true or false expression that is commonly used in our knowledge base. So the sixth thing, is sentence. So this is a really common thing that we always see it. So sentence is just now we mentioned atoms, so it's just like to connect a lot of atoms together to form a sentence. So sentence will like have two things. One is connectives. So connectives are just the signs that we mentioned in the last tutorial. It can be not, and, or a lot of other stuff like this. However, here I would really like to introduce a thing that is really important and really difficult, hard to understand in this lecture. That is quantifiers. So quantifiers are just two different types. One is this, we call it or. The other is some. So I will have a detailed introduction to this. So just remember the sentence here. So the sentence just make the first order logic really like common, can implement a lot of things. Since for example, if you have an or quantifier here, you actually include all possible solutions. So that is really easy compared to propositional logic. Okay, so let's say, so when are we going to use or in sentence? So for example, if in a sentence we appear like all, everyone, or always, or everything, stuff like that. So these are just all things, just everything that appear in that case, and we use the or sign here. Second is some. Probably you can have like someone, or there exists, or sometimes. So these are just some occasions. So what are the opposite of the or sign here? So the opposite meaning is not everyone. So not everyone, which is different with someone. Though I can hardly describe it, but you just pay attention that these two signs are not the same. Not everyone doesn't mean someone. Okay. How about this? So there is a someone. If there isn't someone, it means no one. Or you could say none. Okay, so let's just make some examples. So what if I say all boys are handsome? So how to express the sense? So as you can see, we have all here. Here is a important thing here. So we can have all, and we are going to use some variables, since we all the boys, not just one of them, but all of them. So if the X, then we have to make sure first is they're boys. Okay, so that is boy. This is a function here. They were handsome. So here we use if then sign, which means if the variable here X, it is a boy, then they're handsome. All right. So but how about I say like change a sentence, like some girls love nian. I'm not sure whether it's proper here or not, but I just want to make it this sentence. So as you can see, the thing here is sum. So sum is usually sign, and they have to be girl first. However, here instead of using the if then sign, we use and. So love. And here, instead of just have one parameter here, we have two parameters. One is x, the other is a constant, which is nian. So when we translate this first order logic, we are going to translate from which is some girls love nian. So please always remember when we have the or sign on the or here, when we are expressing something, we always use if and. So you remember, just always have this. And when you have some, then you always, when you express something, you always have and. However, there is some different things. So what does this mean? I'm talking about is when you are expressing something, which is, for example, after R. However, you can absolutely use the and sign in some circumstances. So for example, all how to say, black hair or black boys are handsome. Alright, I just add this thing here. So instead of just have a boy, I have another thing, another function that is black here. So I should so what should I do now? So here I need to have a and sign here. So how to translate it? That is for any kind of parameter here. So it is a boy. First is a boy, and it is a black boy. So that is all black and boy, all black boys. So that is the thing here. So here we have to use the and sign here. Alright, however, when we derive something, we cannot use and sign anymore. So please always pay attention to this, as it is so important. Okay, so next what we're going to do is we introduce some properties. So first, if we have a both are or sign, then it is equivalent by changing the order. And if we have both of them are either sign, we can change their order as well. So let's just make an example, okay? Let's say love, L-O-V-E, love XY. So how do you translate it? That is, everyone loves everyone, alright? And if we change the sequence by putting the Y and X, that is still everyone loves everyone, alright? And the same to this. However, if we have different sign, they're not, wait, let me highlight this. They're not equivalent by changing their order. So if we have a thing here that is like this, then we translate them as everyone loves someone, alright? But if we have this, then it's talking about someone is loved by everyone. That is absolutely not true, alright? So this is the thing here. Another thing also really important, that is about the equivalence. So P here is just a function, so it's equivalent by changing both of the So first we add a not sign to the function here, then we change the and to not sum. All right, so probably we can make an example here. So let's say the function here is sleep. So this means everyone sleeps. So everyone is sleeping. Here we translate is not. So here is not everyone is not sleeping. So, oh sorry, here is none of everyone. None of, just so nobody is not sleeping. So everyone is sleeping. So please pay attention. This is none of everyone. If not everyone, it should be this. All right. So just pay attention. And of course, if we have this, which is also equivalent to this equation. Another, last but not least, there is a thing that is it's also about the equivalent. Sorry, it's about the negation. So for example, if we negate this thing and we want to put negation sign inside the bracket, so the negative sign, the opposite sign of or is actually sum, and this is a thing. And sum for this case, sorry, I lost a bracket there. Okay, so we can also make an example. So we are still, let's assume the P is the sleep function. So here is everyone is sleeping, and if we add a negative sign there, that is everyone is not sleeping. So everyone is not sleeping, and how do we translate this? This is someone is not sleeping, which is equivalent to not someone is not sleeping. So this is the thing. Let's just make some examples. So first, let's say no one sees everything, and I will also teach you how to translate from formula to formula. So first of all, no one is no one. No one sees everything. All right, and we can have a everything here. So we will also have a C function, C's function, as x and y. So x here is person or not person, and just no one. So no one sees everything. So please pay attention. If it is no one, then we can just have this. However, what if say if there is no person sees everything, then it's totally different. So if there's no person sees everything, first we have to make sure that the x is a person. Then we can do the following thing. That is, we have to have a bracket here. So sorry, here is y, and sees everything. Alright, so if no one, then we just assume that the object is not a person, it can be anything. However, if there is no person, then we have to make sure that this object is a person. Alright, so I believe like in the lecture notes, we are just like, we first translate the sentence into another equivalent meaning sentence, then we translate that sentence to a formula. However, that is absolutely not efficient, especially you have a really long sentence. You have to translate the sentence directly, the formula directly. So what we can do is translate this. So we could assume that here is a bracket. So from the properties equation that I mentioned just now, So first, what's the equivalent formula of this? So first of all, we can have translate this, and we are going to have this one, CS540. So we are going to put the negative sign in the bracket. So the first one would be change from or to some, and we also have a CS540. So I think now we can just ignore the bracket here. So how can we translate this? It means everyone. So here is everyone sees or doesn't see, since here is a negation sign here, doesn't see something. Alright, that is, this comes to here. Everyone doesn't see something, meaning no one sees everything. That's true. So we can just like transform the formula into some into another formula and translate the formula into the sentence. So normally, like if you like translate the sentence directly, sometimes we may get some error. So usually the very common error is like you translate this sentence into everyone sees nothing. However, these two things are different. If everyone sees nothing, meaning everyone just see nothing. However, no one sees everything, meaning someone might still see something, which doesn't mean everyone sees nothing. And how to express everyone sees nothing? That is, everyone sees. So you have to follow all the verbs here. So if it's see, then it's just see here. If it doesn't see, then you have a negation sign before that. So sees nothing. So this is nothing, and just sees x and y. However, if you like you want to derive from this formula to this formula, you are unable to do that. So this is the advantage of having the sentence and the formula variation. Last but not least, I would like to talk another very common problems. That is, what if you have something with a, for example, if and then sign. So I just make a example in our lecture notes. So good people always have friends. So first of all, we have to make sure that it is a good people. So if we say every good person, then the only thing that we need to mention is good. However, good people here, another condition here will be a people. So there are two things. So first is good. I can make a smaller term, but that doesn't matter. Remember, even though we have the O sign here, but if both of them are before, you could say a kind of verb that is have here, then here we use and. And then we're going to use this if and then sign. That is friends. Oh, I think I made some mistake. So they have friends, meaning there are some friends that. So there exist some friends. It doesn't mean every friend that is there. Every person is their friend. Yeah, so this is the thing. Um, so first order logic, the last thing I want to mention, that is why it is first, alright? Why is not second logic? And how do we differentiate that? So as you can see here, all the things, all the variables in a function are actually just derived or no, not derived, are just assumed or initiated at the very beginning, and it won't be changed. It can be changed, but how could I say? It won't be changed by other thing. However, if you have some like good person, then this whole parameter will change accordingly to the person, and this will be the second order logic. So first order logic is actually really common in a lot of algorithms, even though we don't express that. But if you are dealing with, for example, the artificial intelligence and the language processing, is really common. So I hope this tutorial is helpful. If you have any questions, concerns, please feel free to leave below. Otherwise, I see you in the next tutorial.